Okay, today we're going to look at trigonometric functions. So in the blue box, we have all of the trigonometric functions defined. So if we have a unit circle, and the diagram I drew is a cleaner example than the unit circle we usually use with all the values, we go over x and up y. Now we're going to redefine each of these things to in terms of trig functions. So sine of t is your y coordinate. Cosine of t is your x coordinate. Tangent of t is y divided by x. Cosecant of t is 1 over y. Secant of t is 1 over x, and cotangent of t is x over y. So if you look at this, sine and cosecant, those are reciprocals. Cosine and secant are reciprocals, and tangent and cotangent are reciprocals as well. So you don't have to remember all of these if you just remember sine, cosine, and tangent, because for the other three trig functions, you just flip them over. So we'll work with examples first. These always work better like that anyway. So let me go to first example. Find the trig functions for pi over 4. So you'll notice I have a unit circle. I think I have it on nearly every page here. So I will just circle the value at pi over 4. So right here is pi over 4. The unit circle value is root 2 over 2, comma root 2 over 2. So this is really simple. At pi over 4, the coordinate point is root 2 over 2, comma root 2 over 2. Sine is represented by the y coordinate. So sine is root 2 over 2. Cosine is the x coordinate. So that's root 2 over 2. Tangent is the ratio of the y coordinate to the x coordinate. So it would be root 2 over 2 divided by root 2 over 2, which is 1. So tangent of t is 1. For the reciprocals, we're going to have to do a little bit of rationalization, but the reciprocal of sine is cosecant, and this is a really important thing to remember. Cosecant does not go with cosine. Cosecant is the reciprocal of sine. So I'm going to write the reciprocals right next to this. So cosecant of t would be 2 over root 2. Secant of t is going to be 2 over root 2. And tangent, or cotangent, is just going to be 1 over 1 because tangent was 1. So this is 1. For cosecant and secant, we rationalize, so we multiply by root 2. And we get, that's going to be 2 root 2 over 2, or root 2. I'm going to highlight that. And so this, for secant, since it's the same, it would also be root 2. And we're just putting boxes around these so that we can see what the values are. So if you're given an angle and it says find the trig functions, go to the unit circle, and sine is y, cosine is x, tangent is y over x, and then flip all those for the reciprocal functions. Okay, so here is the example for even odd properties. So sine, cosecant, tangent, and cotangent are odd functions. Cosine and secant are even functions. And in the box, we have all these properties. So sine of negative t equals negative sine of t. Cosine of negative t equals cosine of t. Tangent of negative t equals negative tangent of t. And the reciprocals will carry through with the same properties as the original function. Okay, so this all has to do with the unit circle. If you have an angle, let's look at this unit circle, zoom in. Let's say we have 60 degrees. Okay, so I land here at 60 degrees. Sine of 60 degrees is root 3 over 2. Okay, so I'm going to write this. This is like a side point. Sine of 60 is root 3 over 2. Okay, well, what happens if I look at sine of negative 60? According to the property here, sine is odd, so it should just be negative root 3 over 2. But here's the why. If I start at the axis and I go backwards 60 degrees, so I'm going to go from the axis down to 300. Okay, so what is the sine value at 300? Well, it's negative root 3 over 2. So when we are using these properties, that's where they come from. It's just because if we go to the unit circle, look at the negative angle, it'll come back and give us exactly what the even odd properties tell us. So it doesn't just come from nowhere. You don't have to memorize it even. So let's go over here. Sine of negative pi over 6. Well, from experience, I know that's the y coordinate at pi over 6, which is 1/2. Okay, so I know this is 1/2 to start if I ignore the negative sign. Since that negative sign, if you look at the property, it comes out to the front. This is negative 1/2, 2. Okay, so for the next example, evaluate cosine of negative 2 pi over 3. So if you look at the even odd property for that one, cosine of negative t is the same value as cosine of t. So if we look at our circle here, I've already drawn this red arrow, so that would represent negative 2/3 pi. And in blue, if I draw it, I'll go to positive 2/3 pi. So we're looking at the x coordinate at that, and it's negative 1/2 for 2 pi over 3, and it's negative 1/2 for negative 2 pi over 3. So that's that property where it doesn't matter if you plug in a negative or a positive angle into cosine, it will always be the same. So this is negative 1/2. Okay, let's look at the fundamental identities. So you may or may not have learned these last year. I'm not sure how your COVID experience was. So we'll talk about this as though you haven't. So we talked about the reciprocal properties with the other ones where tangent is y over x and cotangent is x over y. Well, these are the properties in here. So the reciprocal identities say cosecant is the reciprocal of sine, so it'll be cosecant equals 1 over sine. Secant is the reciprocal of cosine, so that would be 1 over cosine equals secant. Cotangent of t is 1 over tangent t. Tangent t can be rewritten as sine t over cosine t. And just like I said, these are tangent. Earlier in these notes, I said it was equal to y over x on the unit circle. It's because sine is sine is y and cosine is x. So that's why that works. Cotangent is cosine over sine, which again is x over y. So there's a lot of different ways to remember these and think about them. I just try to give you options. Then we have these Pythagorean identities, which we'll talk about in a second. But sine squared plus cosine squared is 1. Tangent squared plus 1 is secant squared. 1 plus cotangent squared is cosecant squared. So those are your Pythagorean identities. Now, if you look at the first one, sine squared plus cosine squared is 1. If you look at it like y squared plus x squared is 1, you'll see why it's, well, that's really just the equation of the unit circle. It's just we're using sine in place of y and cosine in place of x. Okay, so we're going to use those properties and some other things to find the other trig functions in quadrant 4 given cosine t is 3/5. Okay, so let's start with sine. Actually, let's go ahead and solve for sine. So I'm going to use the Pythagorean identity. So I'm going to rewrite it here. Sine squared t plus cosine squared t equals 1. It gives me a value for cosine, which is 3/5. Now you don't plug 3/5 in for t. It's telling you to square 3/5. And we're doing this because we need to solve for sine. And this is the only one we're going to have to solve for like this. Once we get it, we can use it to get all of the other values. So sine squared t plus 9/25 equals 1. And I'm going to rewrite that as 25 over 25 to speed it up. and then we subtract and take the square root. So sine squared t is 25 over 25 minus 9 over 25. So we'll have 6/25. Take the square root of both of these, and we get sine of t equals 4/5, and it's plus or minus. In the unit circle in quadrant 4, you're asking yourself, is the y-coordinate negative or positive? And in the fourth quadrant, the y-coordinate is negative. Okay, so I'm going to write to the side, I'm going to write them in green. Sine of t is negative 4/5. Cosine of t we were given as 3/5. So tangent of t is the ratio of sine to cosine, so it would be negative 4/5 divided by 3/5. So that would be negative 4/3. So those are our sine, cosine, tangent. And then we're going to use the reciprocals for the rest. So cosecant of t is going to be negative 5/4. Secant of t will be 5/3. Cotangent of t is going to be negative 3/4. So that is how you would find the other trig functions given one of them. So you can find all 6 given that using the properties in that box. All right, so let's go to the next one. This one says write tangent t in terms of cosine t, where t is in quadrant 3. So remember, t is just an angle given. Not that it matters in this case, but that's what it is. All right, so to write tangent in terms of cosine, we would need an equation that relates tangent and cosine. And so it would be tangent equals some things on the other side that have cosines in them. So if we go back to our box, we're looking at the Pythagorean identities. Which of these 3 identities has the one that relates tangent and cosine? So it's not the first one, which has sine squared plus cosine squared equals 1. It's not that one. If we look at the second one, tangent t plus 1 equals secant squared t. It doesn't look like it's that one. But what's the reciprocal of secant? And if you go to the box above, the reciprocal of secant is 1 over cosine. So it is actually this middle one we're using. So I'm going to copy that and bring it down here. So tangent squared t plus 1 equals secant squared t. So all this is saying, when something says write tangent in terms of cosine, it's saying solve for tangent. So that's what I'm going to do first before I do any conversion with this. So I will subtract 1. So then we have tangent squared t equals secant squared t minus 1. Take the square root of both sides. Remember, we have a plus or minus to deal with. So we have tangent t equals plus or minus secant squared t minus 1. So in quadrant 3 is tangent. What's the sign of tangent? Is it positive or negative? So in quadrant 3, both the x and the y coordinates are negative. So if you were to divide those, it'd be positive. So we're going to take the positive. So tangent t equals positive. Only thing we have to do is convert secant squared to cosine squared, which you do by doing 1 over cosine squared t minus 1. And now we have written tangent in terms of cosine.